Alright, I think I'm decided I'm just gonna record this entire thing in case I want to edit a video later on, but this is the robot that we're starting with. It's the Foo Fighter, I don't know, whatever. It's just the base, so it's got the battery, the Arduino. The breadboard we needed for all the ultrasonics, but these are gonna come out. And I've got this really nice kit from Capital One. It's just dual servo mount. We're gonna mount basically just like a syringe on top, and we have this small air compressor, and it's called a soda preform bottle. It's here. So I've got the soda preform. This basically pressurizes with air, and then we release it through this tube, which a foam dart just neatly kind of fits in here. So yeah, so when the air comes out, it just pops out. Challenge is I have to be able to fit all of that on this board. Just this single layer board. All this is going to come out. I think the preform is going to go right here. And this breadboard, I'm not sure if it needs to be there yet or not. Basically what I have so far is just Arduino is now mounting. Now the mounting holes didn't exactly line up on all four corners, and so it's just kind of free floating like this, but it works really well. Oh, I don't think I showed this, but this is basically a dual servo mount. I can get pitch on it and I can get yaw on it. And so what's going to happen is you're going to have two axes of controlling this Nerf dart before you shoot it. This is a motor that pressurizes this tube. This tube then feeds into this solenoid valve, and when voltage is given, the solenoid's going to open and it's going to fire this dart. Now the issue is I need to have pretty much straight piping, because if I bend this too far, you see how that kinks? It kinks and you lose all pressure. And so the tough part is figuring out how to pipe this correctly without having any bends. So I think what's gonna happen, at least for the solenoid, is it's gonna come back and just wrap around itself like this. The reason being is because when this turns, it also kinks, so it needs a lot of slack. And so I'm just putting it right behind the servos. As far as where I'm gonna put the motor and this tube thing, I forgot what it's called. Oh, it's a soda preform. So I'm gonna put the soda preform, say here, and maybe further back. And I think I'm just gonna put this like here somewhere. You get the idea. I'll figure it out and I'll show you when I'm done. It's been a bit, I'm back. So right now you can see all the piping is laid out, pressure piping. And so we've got the 6-volt DC motor, which has a little pump attachment on the front. And so this pumps air into the soda preform, and the soda preform holds the air. And then I think this holds like 50 psi. And so once this is pressurized, it comes into this solenoid valve, and then out of the solenoid valve, it comes into this syringe with the Nerf bullet in it. And so when the pressure flies through here, it shoots the Nerf bullet out. And so I think I've got most of the wiring thought out now.
Okay, so here I am editing the video, and I was just talking about how I just finished up the wiring, and I'm just going to explain the problem I ran into and basically the huge multi-day fix I tried to implement on my board, my poor board. So all I wanted to do was take a couple pins, these pins up here, and attach a bunch of other wires to it. And so the way I wanted to do that was to put basically these sockets on it that had long wires, so that I could plug it into the Arduino Mega and also plug wires into the top at the same time. And so I tried drilling the holes out with the drill bit that was slightly too big, and I sort of ruined my board. These pins didn't work anymore. I tried, and yeah, there's no way it worked. And so I pulled out my schematic and I traced the only port I really needed from this, which was the solenoid activation pin. And so I traced where that circuit was going from the hole, and it just comes up to this resistor pad here. And so I soldered a wire to it and it worked, and I'll show you that right now.
Alright, I'm back. It did work actually. Soldering it wasn't too hard. I was a little bit dubious because I can't really tell if it's actually in contact, but I just tested it and it works. I also set up some of the basic wiring. If I can get this to focus. These yellow, white, gray and black cables are for the motors. These two blue ones are servo control lines. These is servo power right here, the gray and purple. But yeah, the basic wiring is set up. The last thing to do is just to find a good spot to put this Bluetooth thing, and then I can start programming and testing everything. But yeah, I think I'm in a good spot. So I found out that I actually need one more circuit built before I can use the Bluetooth adapter. So what happened is the Mega has a 5-volt output on all of its pins, but the receive pin only for this Bluetooth board, the HM10, is 3.3 volts. So I had to wait a couple days to get this resistor kit so I can build a voltage divider. So I'll show you the voltage divider right when I'm done. All right, as you can see, I built my little, if I can get you a good view, my little voltage divider circuit. All it is 2 transistors. The first one's 1000, the other one is 2200. So what happens is the green wire is transmit from the Arduino, which is 5 volts. It goes through the voltage divider and goes to 3.4. The HM10 spec is actually 3.3, but 3.4 is good enough. Next steps is to basically set up a protocol that we're going to use for the Bluetooth communication. So what that means is, how are we going to translate joystick movements into actually powering the motors? All right, as I was talking before, I just figured out the equations for mixing. When we're in the first quadrant, basically the left power just has to stay the same, because no matter if we're going forward or if we're making a hard right, the left power can just be 100% relatively. So, but the right power has to scale. So at 0 degrees, we're going to be going backwards. And at 45, we want that soft right. So we need the motor going at 50%. And at 90 degrees, we just need it all the way front. So it's just like 2 different equations. So the first one is this one, and the second one is that one. The rest of the quadrants are pretty similar, so I don't really feel like drawing it out. So I'm just gonna code this up, and then we can test it, and you'll see how it works. All right, this is the protocol that I came up with. Basically, it's going to be a 1-letter command code, and then it's going to be the command value, and then it's going to end with the new line character. And so in my Bluetooth parsing, you can see that I'm reading from either the first serial, which is USB, or the second serial, which is the Bluetooth. And we're just reading the incoming character and handling it. So if we find, I'll get back to this, what this does actually. We add each character to the serial buffer, which is basically just a string. And so the characters keep building up. Once we get to the end character, which is the new line, we're gonna execute the command. And so right now in the serial would be the command code, the command value, and the new line character. So here we are just deconstructing that, and we're switching along the command code to all the various different features of the robot. So for now, I only have left and right set up. And so if I send L200, new line, that basically means set the left motor to 200. And set left is just a helper I wrote to digital write all my PWM signals to the motor. All right, yeah, next up is just to do the solenoids, I forgot the air pump, the vertical servo, and the horizontal servo. Then once we test all that and just make sure it's working, I'm gonna start writing the iPhone app again. All right, so this is the robot. It basically moves with joystick controls, depending on how you move it. I mean, I can't really record and drive at the same time. But yeah, so it's Bluetooth enabled. I still have to hook up the rest of the controls, which is the pan tilt mount, the charging of the pressure tank, and the solenoid firing, which shouldn't take too long, but I'm worried about the servos and how I want to do them, because if you click it, I want it to move up smoothly, and I don't want it to move too fast, so it's kind of easy to adjust. And I didn't use a joystick because ramping a servo is too complicated. I don't feel like doing that. So we'll figure out. I'll get back to you.
Alright, I thought I'd run through the code really quick if some of y'all are interested. Hey, it's Future Drew here. We're going to skip ahead a little bit since I already explained what the command codes are and how we're moving the left and right motors, but I haven't explained how to charge the air pump or how we're moving the servo mount. And if you're interested to see the full walkthrough of the code from top to bottom, I'm going to leave it at the end of the video. Yeah, so here are the command codes. So S just means fire, basically. So we're going to open the solenoid, which means open the pressure valve, wait a quarter of a second, and close it. A is charging the air pump. So the air pump command actually takes a charge duration in milliseconds. And I'll get back to how that actually times in a bit. Here's the mount move direction. So basically just map the 0, 1, 2, 3, 4 into a mount direction and set it. And then when the time ticks, the servo will actually move in that direction. Okay, let's try to understand what this time tick method does now. So this is actually called every single time the loop function is run. So what it does is check if there's an air pump start time, which is basically when did we set that charge time. And if it's not 0, we're going to see how long has it been since that air pump start time has passed, and we're going to see if that's greater than the charge duration. So basically all this is doing is leaving the air pump on until this charge duration is done. And then we're going to stop charging. We're going to reset our variables and tell the iPhone that, okay, yep, we're done charging. Now the reason why we're not using something like delay is because we want the robot to be able to still move around while we're charging the pump. And so to do that, we can't use delay, because what delay does is completely stop execution. And we don't want to do that. So another method of tracking time is to track the current time always and subtract the time when we started, basically. And that gives us a duration from how long has it been since we started pumping the air pump. And we're basically doing the same kind of thing here. What this is doing is moving the pan tilt mount in the direction that we defined. So that's up, down, left, right, or stop. So if we're not stopped, every mount update rate, which I think is like 20 milliseconds right now, move the mount 1 degree in that direction that we set. And this move mount function isn't too difficult as well. I set some upper and lower bounds. Typically the bounds are 0 to 180, but I wanted some more confined bounds because of the physical limitations of how the servo can move with all the stuff in between. And so all this is doing is checking if we do increase the degree by 1, is it within our set bounds? And if it is, go ahead and set it. And so every time you run this function, as it says, moves the servo 1 degree in the specified direction if the configured upper and lower bounds permit it. That's all it does. Alright, Future Drew here again. Now that we know how the robot was built and how it was coded, we should probably see how it actually works. So I'm going to play a clip of me shooting the robot at myself.
Alright, I'm just testing the range on this. Because whatever. 3, 2, 1, fire. Okay, that hit me. That was pretty cool. Alright, so I had some issues with this solenoid valve here, and turns out that it actually runs on 12 volts, and my old battery was like 7.2, but it was like actually 8. So I went and bought a new 12 volt battery off of Amazon, plugged it in and started working great. But a bonus is this robot's a lot faster now. Okay, compared to last time, it's significantly faster. It's almost like a small RC car now. It's pretty great. And the aiming, of course, still works fantastic.
Alright, I thought I'd run through the code really quick if some of y'all are interested. So there's only really one library that I'm using for this entire project. It's just the servo library. I had to make some edits, which I'll go through in a little bit, but I think we should just go through just the code top to bottom, and I think I can just explain everything. So In the beginning, I've just got some macros, what they're called. Basically, I can just rename some numbers into some, readable things. Like 9 is remapped to air pump pin. So now we've just got some constants that it's used for the code. Uh, I'll explain as I go what they're actually used for. I define an enum called mount direction. It's just defined up here. All it is up, down, left, right, and stop. So up is 0 and stop is 4. That's how this works. Here I've got a command table which I generated with like a table generator online, and this was like the command scheme I sort of came up with. So the way serial works is you can only send one character at a time, and you don't know how long the message is. And so you need a way to figure out what you're sending and when to know when a command is done. So what I basically did is the first letter is going to be your command code. Any letters between the end command character and that first letter is going to be the command value. So if you want to set the speed of the motor to 200, you would send L200 and then the new line character, which is just \n. So here's some setup code. So we're just starting up our USB and Bluetooth serials. Serial 1 is connected to the Bluetooth, by the way. We've got the air pump pins and the solenoid pins set to outputs. We're attaching our servos, which basically just set up the horizontal servo pins and that kind of thing. It also moves it to a nice starting position, which I figured out by just guessing it. Alright, now we're doing some timing setup. So we're getting the current time from the Arduino, and don't worry about this. And we're starting up our serial lines. And so once the setup code runs, the loop is going to run indefinitely now, because that's how Arduinos work. There's setup and loop. Setup is where you set up one time, and loop is when it loops forever, which makes sense. So every time the Arduino loops, which is like incredibly fast, I'm not exactly sure how fast it goes, but don't worry about it. Just assume it goes stupid fast. We're getting the current time every stupid fast time this loops, and we're calling a function called timeTick, which I'll get to in a bit. But we're also checking if we have any characters available from the USB or Bluetooth lines. And let's just say we're only going to stick to USB for now. Bluetooth works in the exact same way. So on the serial line, we have this incoming character. So we're getting that character, and we're handling it, quote unquote. And so here we're handling the car. So if it's not the end command car, we're just going to add it to a string. So serial buffer is defined up here. It's actually just an empty string in the beginning. But as you add those characters, let's say L200, that's going to be added to that string. And once we receive that end command car, we're going to execute the command, because now we know we have the full command in our serial buffer. So we're going to get the command code, which is that first letter. We're going to find the end of the command, which is that index of the new line. And we're going to get the command value, which is basically everything in between. And now we can switch over the command code, and according to our diagram, we can set we can send the commands to the correct places. So set left and set right are just setting our motor speeds. It's some helpers I wrote for myself. Basically, if the value is positive, it's moving the motor forward. If the value is negative, it's moving it backward. And if it's 0, it's turning it off. And I'll explain more about why this is analog right and what PWM motor control actually does in a bit. Where were we? Yeah, so here are the command codes. So S just means fire, basically. So we're going to open the solenoid, which means open the pressure valve, wait a quarter of a second, and close it. A is charging the air pump. So the air pump command actually takes a charge duration in milliseconds, and I'll get back to how that actually times in a bit. Here's the mount move direction. So basically just map the 0, 1, 2, 3, 4 into a mount direction and set it, and then when the time ticks, the servo will actually move in that direction. And this is something that's unused right now, but this is basically used before to load the Nerf dart, because I didn't want to put pressure on the servos as I was loading the Nerf dart, and so I wanted to turn them off. And I thought that opening the solenoid would make it easier to open, but turns out it's just the friction that makes it so hard. So, okay, let's try to understand what this time tick method does now. So this is actually called every single time the loop function is run. So what it does is check if there's an air pump start time, which is basically when did we, set that charge time. And if it's not 0, we're going to see how long has it been since that air pump start time has passed, and we're going to see if that's greater than the charge duration. So basically all this is doing is leaving the air pump on until this charge duration is done. And then we're going to stop charging. We're going to reset our variables and tell the iPhone that, okay, yep, we're done charging. Now, the reason why we're not using something like delay is because we want the robot to be able to still move around while we're charging the pump. And so to do that, we can't use delay, because what delay does is completely stop execution. And we don't want to do that. So another method of tracking time is to track the current time always and subtract the time when we started, basically. That gives us a duration from how long has it been since we started pumping the air pump. And we're basically doing the same kind of thing here. What this is doing is moving the pan tilt mount in the direction that we defined. So that's up, down, left, right, or stop. So if we're not stopped, every mount update rate, which I think is like 20 milliseconds right now, move the mount 1 degree in that direction that we set. And this move mount function isn't too difficult as well. I set some upper and lower bounds. Typically the bounds are 0 to 180, but I wanted some more confined bounds because of the physical limitations of how the servo can move with all the stuff in between. And so all this is doing is checking if we do increase the degree by 1, is it within our set bounds? And if it is, go ahead and set it. And so every time you run this function, as it says, moves the servo 1 degree in the specified direction if the configured upper and lower bounds permit it. That's all it does.